Hello, everyone, and thank you so much for joining us today. I'm your host, Adam Lieberman, Distinguished Engineer and Head of Artificial Intelligence and Machine Learning at Finastra. We're welcoming you for this live meetup, one in a series, part of our Hack to the Future Global FinTech Hackathon. Hack to the Future is a FinTech movement igniting a world of financial sustainability, inclusion, and empowerment. Building on the successes of our previous hackathons, to redefine finance for good and build an unbiased fintech future, we continue to use our position in the market to inspire the fintech space to be open by default for everyone. This year, we aim to drive engagement beyond our global fintech ecosystem with three key themes that are inclusive and open to all: ESG, embedded finance, and DeFi. Today, we'll be talking about DeFi with a focus on NFTs, non-fungible tokens. Our innovation team has been experimenting recently with NFTs, and we thought we would share our learnings with you. So we're doing a NFT Tuesdays series, which we've started last week, and will run throughout the hackathon. In this series, we're going to take you on a step-by-step journey to create your own NFT collection. So going from creating the art, which was last week, to programmatically generating the collection, then assessing its rarity, and finally doing a bulk upload to an NFT marketplace. Today, we'll focus on programmatically generating the collection. And for that, Haylee Anderson is joining me today. Haylee, can you please introduce yourself?
Yeah. Hey, everyone. I'm Haylee Anderson. I'm a data scientist, and I work on DeFi projects and machine learning and metaverse explorations here on the innovation team.
Awesome. Now, before getting into the programmatic generation, let's first watch a video summarizing the end-to-end NFT journey. And now, Haylee, over to you.
Yeah, so once again, I'm Haylee. I'm here with Adam, and we're super excited to present this session on programmatic NFT generation. So for a quick recap on our previous NFT session last week with Sebastian, in his session, Sebastian went over what an NFT is and how we can actually create the base art of a PNG file in Adobe Illustrator and in PowerPoint. In that session, we created some different layers such as background, hoodie, face, laptop, and hair with multiple variations in each layer. And then in this session, we're going to build upon that and actually put to use those different assets. So the question is, what is generative art? So there's a great definition of it by Philip Galanter. So he states that generative art can be any art practice where the artist creates a process, such as a set of rules, a computer program, or other procedural invention, which is then set into motion with some degree of autonomy contributing to or resulting in a completed work of art. So what generative art can either be based on predefined rules, or it can be randomness and statistics, or it can be completely generative through a model like generative adversarial networks where we can learn from the data and then create some new, never before seen variations. So in this series, we're going to focus on using statistical rarity and randomness to assemble combinations of our artwork files. And then eventually we're going to let a computer program handle the generations.
So in terms of generative art for NFTs, like Haylee had mentioned, there's two very popular kinds. We have statistical combinations and we have generative modeling. With statistical combinations, we have a series of different options per layer and a chance of occurrence. For example, here we have 4 different faces, we have 4 different hairstyles, there's 4 hoodies and 3 laptops, each with their own associated statistical rarities. You can see that, all faces have an equal chance of occurrence, but if you look at the pink hair and the orange laptop, they're a little bit more rare. Using randomness, a little statistics, and some code, we can programmatically generate combinations of these assets to create our different NFT images. On the other side, we have what's called generative modeling. And generative modeling leverages large amounts of training data, and it passes into these various deep learning models like a generative adversarial network, which we call a GAN, or a variational autoencoder, which we call a VAE. And really the goal is to learn how to understand, to really generate and create these new, never before seen outputs. And for some quick context, a GAN is a model that takes real samples and fake samples it generates and tries to determine which is the real and which is the fake. It continuously learns to get better and better at detecting fake samples, while also getting better and better at creating real ones and detecting real ones. It's kind of like 2 neural networks that are playing a game against each other. The variational autoencoder, on the other hand, is more like a compression algorithm, where we take a sample, we make it, really small. And then from that really small sample, we learn to make it bigger and reproduce the original sample. It's sort of like compressing a file and double clicking it and opening it back up to see the contents. These models are, they're pretty complex and there's a lot of math under the hood. So we're not really going to get into it for this session, but definitely feel free to ping us on the Discord if you're interested to learn more. With generative models, we do need access to many, many images and, very strong computational hardware to create, this very clear and visually accurate output. And also, to get the required data, you can actually use the statistical combinations approach and feed that into your model. So in our webinar today, we're going to focus on statistical combinations, as this is probably the primary way that you see in most of the large NFT collections that are out there. To do so, we are first going to structure our art files from a previous webinar session that Sebastian had run. We're going to understand and structure our metadata JSON files, and we'll set some statistical rarities on our different asset traits. We'll write a little bit of Python code to handle the generation of our assets. And then we're going to create a fun video montage of all the different NFTs that we've generated. So in short, we'll have, one nice script that's capable of generating tens of thousands of NFT images for your next collection. So let's get right into the code. The first thing that we're going to do is we're going to check to make sure that you have Python installed. So what I'm going to do, I'm on a Mac operating system, is I'm going to go into my terminal and run Python -- version. You'll see that I'm on Python 3.76. It might be a little bit small, but if you don't have Python installed, there's this distribution called Anaconda. And basically Anaconda has a nice graphical installer. You can download it. There's Python 3.7, 3.8, 3.9, many different versions of it, but they have a lot of the libraries that we'll be using already pre-installed. So you don't have to go install them one by one. The next thing that we'll be doing is using Jupyter Notebook. And here's a link to Jupyter. Jupyter Notebook provides a cell-like interface for us to structure our code in these different cell blocks. So it's really nice and easy to follow. It's almost like reading, through your notes in a notebook. So to actually launch a Jupyter Notebook, once you have Python and Jupyter installed, you can go into a terminal window. cd into the directory that we're going to provide you, and you just run the command Jupyter space notebook. And I already have mine launched right now, so I'm not going to relaunch it, but that will take you to a localhost session right here, and you'll be able to see everything that's in the directory that you ran it from. So I'm going to jump into my Generate NFTs notebook, and we'll get started. So the first thing that we're going to do is take a look at the assets that we created from Sebastian's session. So in the link that we'll provide to our GitHub repository, you'll find a meta.json file, you'll find a folder called assets, and you'll find a Jupyter notebook called Generate NFTs. So if we look into assets, we've provided you with a base set. So we're going to be generating some fun hackathon characters. Looking at the backgrounds, we have a few different options. We've got a white background, which I'm going to pull up. We've got some pink backgrounds with stars. There's some purple ones. We've got some different faces. We've got some different hair options. We've got some short hair, some long hair. We have hoodies, and we have a laptop. And what we want to do is take, all these different variations. We see that we have 3 different laptops. There's 5 hoodies. We have multiple hair options, and we want to programmatically create these different combinations. So to get started, we're going to see that, we have a folder called assets. We have all these different files with their names, and then we're going to pop into our meta.json file. So when you open it up, you'll see that we've already filled it out for you. I'm going to zoom in a little bit. And it's basically almost like a dictionary. And we have these different keys. So we have a key called layers. And then within layers, we have keys that reference all the different folders that we have. One for face, hoodie, laptop, hair, and background. And you'll see that we've included the actual path to all these files. So what you'll do is if you have your own set of images, you'll come in and replace layers with all the file names that you have and all the different directories. We also have a key called order, and this allows us to specify the order we want to apply our images in. So we want to first put a background, then a hoodie on it, then a laptop, then a face, and then hair on top. And this will create our nice image. We have a key called N, which is how many NFT images we actually want to generate. And then we have a collection name. So this is where the output to all our NFT images will be. You probably noticed that there's a bunch of numbers in each of these small layers. And these are actually rarities or chances of occurrence. So for example, if we go look at face, I have this green face. And maybe I want to make it so it's pretty rare that a green face gets generated. So out of every 100, we generate maybe 2. So I can set the statistical rarity for all my different traits. And one really important thing to note is that we need it to sum to 1 in all the individual layers. So you see here that we have an equal chance for faces 1 through 4 to appear. But then, we have this one rare chance for this green face to appear. And you can see the same for, if I pull into the hair layer, that, we have the purple hair and the pink hair, which are going to be a little bit more rare. So once we have this all filled out, we can go back to our notebook and get started. So throughout this notebook, you'll find a lot of instructions, and we're going to go through most of the code segments here so that you understand what's going on behind the scenes. And the first thing we need to understand is about actually accessing the different files we have on our machine. And to do so, we're going to use a Python library called glob. And glob basically just lets us specify a directory and access the contents inside of it. So if I want to see, what is everything inside my assets folder, where I'm storing all my individual trait files, I can run glob.glob assets and put a little star next to it. And it's going to show me I have assets background, face, hoodie, hair, and laptop. Now, if we look in assets, we have, individual files within it that we want to access. So we could iterate over it and say, show me everything that's in assets, background, and it will list out all these individual files for you. And that's what we're going to do next. So now I'm just going to open, one image from each of these folders using the Python pill package. And pill is an image processing library that we have. And so I'll loop through all these folders. I'll grab, one image to display. And then I'm going to show you something called alpha composite. So for all of those images that I grab, the background, hoodie, the laptop, the face, and the hair, I can loop over these and call image.alpha composite to actually apply the images on top of each other to generate our final image. So these are the two things that we'll be using pretty heavily. We'll be using Glob to get access to all the individual trait images. And then we will use Pill's alpha composite once we've selected, the images that we want or the file names that we want to actually apply the images on top of each other. So next, we're going to open this meta.json file that we have to get access to all the information that we've filled out. So I can run json.load our file, and you'll see we have the exact same printout. So now we have a Python dictionary, and we have access to the different keys. For example, if I wanted to print out the rarity for our purple hair within hair, I could run this line right here. We can print out the black hoodie. I can get, the number of NFTs that I'm going to generate, and then also grab the collection name just by referencing that individual key within our Python dictionary. And you'll see that the printout right here in our cells. So now we're going to get to the fun part, the actual programmatic generation. So we're going to use a few more libraries that we're going to import here. If you are missing them, you can run this command, which is pip install, and then you can put in the package name. So if you don't have NumPy for some reason, you can run pip install NumPy and then just run the cell here, and it should import it for you. So I've got all these libraries already installed on my machine. So I'm just going to run this cell. And now I'm going to pull out just a few variables that we're going to use just to make it a little bit easier to follow. So I'm going to grab the layer order. So just a list of the orders in which we're going to apply the images, the number of images we're going to generate. I'm going to grab our collection name. And then I am also going to just create a list of all the files that we have. And I'll print out all file names right here. You can see it's just every single individual trait PNG file that we have across all our assets. So now I'm going to create a couple dictionaries. And the reason I want to do this is it's going to be kind of a lookup. So it's going to make it nice and easy for me to just reference. One thing that we don't want to do is continuously open the same images multiple times. So I'm going to open all the individual images at the beginning, so then I can just reference them in this dictionary, which is going to save us a lot of time and a nice amount of computing power. So the first dictionary is going to be called dfile to pill. So this is going to give us a key that we can look up directly to an image. So here you can see that I can just reference the pink stars and the image is already there and it's opened. If I wanted to grab, let's say, the purple hoodie, I can just take that file path and replace it right here. And it'll open the purple hoodie. And I just resized it to 128 by 128, just so it's nice and small in our cell. The next thing I'm going to do is create a mapping from an individual file name to the actual weight that we've set. So here you can see that we have, the white background has a 0.5 chance, and the purple background has a 0.4 chance. So these are going to be two dictionaries that are going to be useful for us in the next couple segments of code. One other thing we need to check for is how many NFT images can we actually generate? What is the total number of combinations we can actually create? because if we can only create 1,800 combinations, we can't specify, we want to generate 2,500 images because 1,800 is the max. And for these different traits, if you wanted to calculate the number of combinations, you basically just need to look in each folder and count how many individual traits you have, and then multiply that number across all the different folders. So if we had, 5 backgrounds, if we had 2 faces, and we had 3 hairs, our total number of combination would be 5 times 3 times 2 would be 30. So here we have a cell block that will actually, go over our layers and calculate the total number of combinations. So we see that the maximum number of unique images we could generate using all of our individual traits would be 1,800. So now we're going to do a quick check, because in our meta.json file, we have the end parameter, which specifies how many images we want to generate. So we're just going to make sure that we are not trying to generate too many. So it says, okay, 250 is definitely less than 1,800. So we are all good to keep going. Now we need to make sure that we have a directory that's actually been created to store our NFT images, because we did specify a collection name of hacker generations to save all these images to. So we can use and access the operating system from the Python OS module, and we'll just check, if the path exists. If our collection name exists, we're okay. If not, let's create it. So I ran this, and you'll see that all of a sudden this hacker generations folder popped up that's empty. So we now have a place where we can store all of our hacker generations. So moving into the fun part and the meat of the notebook, we're actually going to create the NFT combos right now. And there's a lot of different ways that you can do this. The way that we're going to show you is a clever and I would say a little bit more statistically minded. But what we're going to do is we're first going to generate all 1,800 possible combinations of assets. And then we're going to calculate the statistical chance of that NFT asset that was generated being displayed. And then we're going to do a random sample over that probability distribution for the number that we want. And I'm going to show that to you here. But to make that sound more simple, we create all these different combinations of NFTs. They all have a chance of occurrence. And we have this probability distribution that we're going to sample from. So I'm going to show you down here what it looks like after we run these few segments. But basically, you'll see we have 250 different combinations. So we kind of have this array that's a list of lists, but each one has a randomly selected set of traits for it that make up one individual NFT. And just to show you that there's 250, we can run length of selected. So now we actually want to create the images. So we have, just an array of lists that has a file path. I'm going to rerun this and show you, but we don't actually have the images. So this is where it's very useful. Now we can iterate over our selected, just reference and look up the image, and then use that pill, apply composite function on top of those images to generate that image. So I'm going to run this cell, and I'm actually going to open this folder that's empty because you will start to see all the magic happening here. So as I'm running this, we're going to see 250 NFTs that are all individual and unique being populated. So in just a couple seconds, it should finish, and it will give us a notification at the bottom of the cell. And we're almost there. There we go. We created 250. So it started at 0 and it goes through 249. So let's pull up just a couple of these so we can see what they actually look like. So here we got one. This was the 121st one that was generated. We have 82. This is a really rare one. It's got the orange laptop and purple hair. Then we got a few more. So really cool. And just running a couple of lines of code, we've saved so much time. We've been able to create completely unique NFTs. or NFT images that incorporate the statistical rarity with it. But, like we open this NFT and it would be really difficult now if we wanted to do, an upload for us to reference the image and then type in, what are the traits behind it, right? We have to look at it and say, oh, it has the purple hair, it has the black hoodie, it has, this laptop, it has this background. So it'd be really nice for us to generate a file that holds all our traits. And that's what we're going to do here. We're just going to loop over all of the assets that we have and then just structure it and create a nice CSV file. So I'm going to run this segment and I'll take you through the 2 files that it generates. So we have one data frame. It just has a file name. So you'll see we have 0 going down. We have the layer and we have the actual base asset or the image that it corresponds to. So if we look at 0.png, which I'm going to bring up, it has face 3, it has black hair, it's got the purple hoodie, the purple laptop, and the white background. And if this is a little difficult to read, we can also pivot it, and that's what you see here. So we just kind of expand out and now it creates a column instead of having one layer column. So this will be very useful in our future sessions where we talk about analyzing statistical rarity of the generated collection and then also doing a batch upload to an NFT platform. So now I'm going to run this line of code and it's going to create a grid of our 250 images. And it's funny because actually creating this figure, this grid, and opening all these images actually takes longer than generating 250 unique combinations of it. But let's give that 1 or 2 seconds and it should pop up and show us all of our different NFTs or NFT images. So it's really tiny. I have the grid compressed, but if you want to play around with it later, you can always change the figure size to be bigger. You can resize the images. Here I have them as 128 by 128, and you can also change the number of columns. Now, if we just want to pull up an image, we have a couple lines here. So I can specify an index, which just corresponds to a file name. So if I wanted to open, let's say 10.png, I can just run this and it will open for me. We want to open 100.png. There we go. And we can run this line to get some information around the file. So in just a few short minutes, we've been able to run just a couple lines of code and really generate a full programmatic collection. Now it'd be pretty cool, since we do have 250, to create a video montage of them. And there's a library that you can pip install called MoviePy. And we have a function here which will allow you to specify where your folder is and a frame rate. And we'll actually create a quick montage. So I'm going to run this function, and in a short second, it should start generating a video for us. And you can see it right here. So the video is done, and I'm now going to pull this up. And we have a pretty cool video montage that you could share that goes through every single NFT image that we've generated. So if this is not fast enough for you, we can further increase the frames per second. So let's do one at 20 frames per second. We'll wait a couple seconds, and then we'll have a really blinding video. So here we go. Now we have this code, structured in these cells just so, we could help everybody understand. But, it is a little cumbersome to run, cell by cell. So what we usually like to do is clean up our code a little bit and write it in a more object-oriented style. So we do have this class that we've created for you. And, it's a great exercise for you to structure your own class using these different functions and code segments we've provided. But, we're not going to go through this entire class, as it is made up just of all the different functions and code cells that we have. But now, going forward, if you just want to use this cell, you can open your JSON dictionary, which we had here, this meta.json. You can say n equals nftgen, which is the object for this class that we've created. And then you can call .generate, and it will run every single thing that we just showed you. So this is how you take just a few PNG files and a few different traits. You can set their statistical rarity, and with a few lines of code, you can generate a full collection. So what's next? So in our next webinar, we are actually going to build on this code base, and we're going to take a look at the collection that we've generated and look at a few different ways that we could assess the rarity of it. We're also going to build a small Python application in Streamlit from that code base. So we've got some really exciting things coming up. So now let's take a look if there are any questions.
Looks like we have one question from JR. They said, new to NFT field, are there policies or rules to how you can protect a video or image NFT that you have created?
Oh, interesting. Yeah, that's a great question, JR. I think if you look at the concept of NFTs, right, they are digital signatures. So when you do upload that to a platform, you do have that trace that it was coming from the address that you uploaded it. Haylee, do you have any more insight around that?
I would like to say, like, one of the biggest concerns about NFTs is the copyright protection of your art. So there's like no way, like good way to like protect it except for, keeping that digital archive of your original work along with like, your date that was created.
Yeah, that's
and
a good
also
point.
like making sure you have it in like making sure your wallet is safe.
That's a really great point, JR. In the past, there were issues. Like if you looked at some of the NFT marketplace platforms, a lot of people were stealing art from sites like DeviantArt and uploading it as NFTs. So we've actually seen a few of these art platforms that are doing a little bit of machine learning, and they'll tell you if your art is showing up on an NFT marketplace, which is really nice from the art platforms. Let's see, are there any more questions? For our viewers, if you have any questions, feel free to pop them into the chat and we'll answer them. Nope. Well, thank you everybody so much. If you do have any further questions, we are on Discord. We will send out a link to the code. If you have any questions around it, feel free to message Haylee and I. If you want to learn more about generative modeling, we're also here for that as well. So thank you, everybody. Look forward to seeing you in the next sessions.